Hey, Algebra 2, Lesson 4, from circleometry to trigonometry. I did just skip Lesson 3, which is a really interesting lesson in the history of math and how people thought that the sun rotated around the earth, which isn't true. All right. So first of all, we're going to review a little bit of geometry, the trigonometry we learned in geometry. We're not going to use calculators. We're going to find the lengths of the sides of the right triangles, each of which has a hypotenuse of length of 1. Little refresher here. It's not the best. Let's try again. Oh my goodness. That's better. So we have 30, 60, 90. Our base triangle, which we learned in geometry, it's our 30, 60 triangle. So across from the hypotenuse is 2x. Across from the 60-degree angle is x root 3. And across from the 30 is just plain old x. And then we've got our 45, 45, 90-degree triangle, which says this is x, x, and x root 2. So we can just set up some basic ratios, and I would get 1 over 2x equals, let's do AC, over x root 3, cross multiply, 2x AC equals x root 3. The x's cancel, divide by 2. I have AC equals square root 3 over 2. And then BC, I'm going to do the same ratio. 1 over 2x equals BC over x. Cross multiply, I have 2x BC equals x. Those x's cancel. BC equals 1/2. Okay, you can go ahead and do the other ones. It's the same type ratio. In fact, it looks like that one can go over there. Cool. Good work. Another opening exercise, given the following right triangle with the measurement of angle A equals theta, find sine theta and cosine theta. If you remember, this is where we do sine to the negative 1 of theta equals, toa. Sine is opposite over hypotenuse, so opposite over hypotenuse, 5 over 13. Get up my handy dandy calculator. Sine negative 1 of 5 over 13, 0.395. Then cosine theta. Cosine is adjacent over hypotenuse. I'm not actually writing these right, am I? Sorry about that. Fix that. Cosine. 12 over 13, 0.395. Cool. And it should be the same because it's the same theta. All right, that was a good review. So suppose that point P is the point on the unit circle obtained by rotating the initial ray through 30 degrees. I've got point P, initial ray, which is right there. I'm rotating it 30 degrees. Find the sine of 30 and the cosine of 30. I just wrote that special triangle down again. So if we are doing sine of 30, I've got SOHCAHTOA. Sine is opposite over hypotenuse, opposite over hypotenuse. I get x over 2x, which is just plain old 1/2. And then cosine of 30 is adjacent over hypotenuse, ca. Adjacent is 3 root x. That's wrong. X root 3. I could erase it, but I want you to see I make mistakes too. Over hypotenuse, which is 2x. X's cancel. I have root 3 over 2 for cosine of 30. So what is the length of OQ? Hold on. Sorry, I needed to see OQ to talk about what the length is. So OQ is this segment right here. We just figured out what the sine and cosine of that 30-degree angle are, or is, proper English, right? So OQ, if I've got my 30, 60, 90 triangle, is that one right there. And we did figure out that that is root 3 over 2. Because my hypotenuse is 1. What is the length of QP of the vertical leg of our triangle? So that one right there we calculated, and we got 1/2. That was when we did opposite, so sine, the sine of 30 degrees. Oh gosh, we just did this. The sine of 30 degrees is 1/2, and the cosine of 30 degrees is root 3 over 2. I did things out of order, and for that I apologize. So suppose that P is the point on the unit circle obtained by rotating the initial ray 45 degrees. So we're right there. Find sine 45 and cosine 45. So sine of 45 degrees is opposite over hypotenuse. Look at my 45 degree triangle. I have x root 2, x, and x. Sine opposite over hypotenuse. So I've got opposite over hypotenuse. We don't like radicals in the denominator, so I'm going to rationalize that, and I get root 2 over 2 for sine 45. Very fun. Cosine of 45 is adjacent over hypotenuse, and that's going to give me the exact same answer. Suppose that P is the point in the unit circle obtained by rotating the initial ray 60 degrees. So this is 60, that means that is 30. And I still have my hypotenuse as 1, which we're not going to actually say it's 1. 2x, x, and x root 3. So we are 60 degrees through, so we want sine of 60. Sine is opposite over hypotenuse. Opposite over hypotenuse, so I've got x root 3 over 2x, which gives me root 3 over 2. And then cosine 60, which is adjacent over hypotenuse. So I have x over 2x, or 1/2. Okay, moving on to 150 degrees. Find sine of 150. Okay, 150, if I am going this way 150 degrees, I'm taking away 90, and that leaves me 60 left. So this would be 60 degrees. So that is 30 degrees. We always want to get it into our standard triangle. So for these next, suppose that, okay, find sine of 150 and cosine of 150. This right here is called our terminal ray. Which is very helpful because now I can get that triangle there so I can analyze the triangle, because we don't do sine of 150, we do sine of our basic triangles. This right here is called my reference angle, which is 30 degrees. The reference angle always goes back to our horizontal axis, always. So when we say initial ray rotates through 150, we want to talk about the reference angle. That's what we're always going to refer back to. So I'm going to label this as x. The hypotenuse is 2x. And the bottom is x root 3. So if I'm trying to find sine of 150, I'm really finding sine of my reference angle, which that's their symbol for reference angle. Sine of 30, which equals opposite over hypotenuse, 1/2. And then cosine of 150 would be cosine of our reference angle. Opposite over hypotenuse, x over 2x equals, sorry, cosine is adjacent over hypotenuse. Don't judge me. I mean, you can, but so adjacent over hypotenuse, x root 3 over 2x, which is root 3 over 2. Cool, so we learned through this exercise what our reference angle is, which is extremely important. We always go back to the horizontal axis, and I need to point out a mistake that I just realized I made. I've got my xy axis. If I look at just the x-axis, over here the x-axis is positive, over there it's negative. So this value right here would in fact be negative. My radius is not negative, 2x, and then my horizontal distance, my vertical distance x is also not negative, but the root 3 is. So my cosine of 30 is, my cosine of 30 is my reference angle of 30 degrees. It's actually negative root 3 over 2. That's a hugely important point that I failed to make. So for that, I apologize. But yes, we look at the xy axis and the positives and negatives. So we've talked about quadrant 1 and quadrant 2, where my x-axis is negative, my x-axis is positive. Next, we're actually going to get into quadrant 3, where my y-axis is negative also. So that's where we're heading next. We already discussed quadrant 2. We're good. I did that really cramped in the last slide. Okay, quadrant 3. So in quadrant 3, no matter what, I've got my terminal ray, which I'm going to always calculate what my reference angle is. When we get into quadrant 3, that is in between 180 degrees and 270 degrees. But we always calculate from our terminal ray back to the horizontal axis to get our reference angle. And that is how we calculate sine, cosine. But we do need to pay attention to our positive negative signs, where the x-axis here is going to be negative and the vertical distance is also going to be negative. Cool. So the terminal ray rotation of theta lies in the third quadrant when it's between 180 and 270. Our reference angle is formed by the terminal ray and the x-axis. Reference angle, sorry. Formed by the terminal ray and the x-axis. So we can always say that is equal to theta minus 180. Will be an easy one to calculate, right? All right. We always go counterclockwise all the way, so our terminal ray does that whole rotation to get into quadrant 4, where our x values or horizontal values are positive and our vertical values are negative. To get all the way over here, we are in between 270 degrees and 360 degrees. So we're in our fourth quadrant. We always look at our reference angle. Yeah. If I look at, let's say our terminal ray rotates 315 degrees. So what is the cosine of 315 degrees? If I take 360 minus 315, I actually have 45 degrees left. So our reference angle is 45 degrees. So if I want the cosine of 315, I actually want the cosine of 45. If I want the cosine is adjacent over hypotenuse. So I've got adjacent over hypotenuse. Adjacent is positive, so my cosine is going to stay positive. If I do sine, I've got opposite over hypotenuse, which is going to be negative. I'm actually going to have negative sine of 45. Cool. So this would be root 2 over 2, and that would be negative root 2 over 2. Cool. All right, so quadrant 1, my cosine and my sines are both positive. Quadrant 2, sorry, let's do this. That's how I always remembered them. I've got positive cosine, so quadrant 2, my cosine is negative, my sine is positive. They're both negative, and my cosine is positive, my sine is negative. Both positive, both negative, and they trade off. Suppose that P is the point on the unit circle obtained by rotating the initial ray counterclockwise through 120. So I'm at 120. That's not far enough. Oh goodness, I thought I was erasing. Yeah. So I'm trying to figure out what my reference angle is. So 120. That means that I am 60 degrees away from horizontal. So my reference angle is 60 degrees. So I'm going to take sine of 60 and cosine of 60. My cosine is going to be negative. My sine is going to be positive. Go back to that triangle we have. We've got sine of 60 is square root 3 over 2, and cosine 60 is negative 1/2. Suppose that P is the point on the unit circle. Rotate counterclockwise 240. So 240 is more than 180. It's going to be over here. 240 degrees. This is 270. So I'm going to take 240 minus 180. It means I'm going back 60 degrees. So both of those are negative. So the sine of 240 is negative sine of 60, negative cosine of 60, negative root 3 over 2, and negative 1/2. Suppose that P is the point on the unit circle obtained by rotating the initial ray counterclockwise through 330. So I have 30 degrees left to get to 360. So the reference angle is 30 degrees. Find the measure of the reference angle. So I want sine of 30, cosine of 30. I think sine is negative here. Adjacent over hypotenuse. So opposite, yep, so that one is negative. So I've got negative 1/2 and positive root 3 over 2. We're learning the unit circle here. Pretty exciting. I have a copy of this for you. I will get it to you when I see you. But this is all of it. It's pretty cool. I've memorized, so I've got sine, cosine, tangent. The unit circle, my radius is 1. So sine, is my y value of the unit circle. Cosine is my x value of the unit circle. And tangent is y over x. Because these are all written in coordinates. So I've got x, y, sine. If I look at number 5 from the exercises, I did sine of 330, which is negative sine of 30, which was negative 1/2. Cosine of 330 was cosine of 30, which was root 3 over 2. And then tangent's always going to be y over x. Cool? Cool. That's it. Oh my gosh, that's it. That was long, but very necessary. Cool.